Doomsday Glacier, a vast expanse of Antarctic ice formerly named the Thwaites Glacier. As temperatures rise connected to human activities, it's melting.
Imagine an iceberg the size of a major city breaking away and exposing a hidden world sealed beneath Antarctic ice for centuries. Far below the frozen surface, scientists discovered a thriving ecosystem where sunlight never reaches and strange marine life survives against all odds. The finding is transforming what we know about life in extreme environments and may even offer clues about life beyond Earth. What creatures are living on this newly exposed seafloor? And what secrets have they kept hidden beneath the ice? The giant iceberg's sudden break. On January 13, 2025, a colossal iceberg roughly the size of Chicago detached from the George VI ice shelf in Antarctica. Designated A84, this massive chunk of ice measured about 19 miles long and 11 miles wide, covering over 500 square kilometers. Satellite imagery from NASA's Terra and Aqua missions captured the dramatic moment as the iceberg broke free and began drifting with powerful coastal currents. For centuries, beneath where A84 had rested, lay a seafloor shrouded in darkness and isolation, sealed beneath an ice thickness equivalent to a 50-story building. This calving was more than a geological event. It exposed a section of the ocean floor previously inaccessible to humans and untouched by sunlight or surface nutrients for possibly hundreds of years. The ice shelf above blocked photosynthesis, cutting off the usual food sources that sustain marine ecosystems. Temperatures hovered near freezing, pressure at those depths could crush steel, and conventional wisdom predicted that little life could survive in such a place. Marine biologists expected the seafloor to be barren, or at best, support sparse, struggling organisms clinging to existence under extreme conditions. At the moment A84 broke away, an international research vessel, the RV Falkor 2, operated by the Schmidt Ocean Institute, was nearby conducting deep-sea biodiversity studies in the Bellingshausen Sea. These researchers had been limited in their planned expedition route due to sea ice blocking some areas. But when news of the iceberg calving came through, the team seized the opportunity and shifted their focus immediately. Within 12 days, they were on site, poised to explore the newly revealed seafloor and uncover what had been hidden for so long. Their rapid decision to pivot their expedition was a stroke of luck, a chance to witness an environment that no human had ever seen. The true mystery was what biological community, if any, had survived in this under-ice realm where sunlight and surface organic material could not reach. What secrets lay beneath this vast, dark, and frozen expanse? The team's curiosity and preparation set the stage for a groundbreaking exploration that would challenge everything they thought they knew about life in extreme environments. This event was a rare moment when nature's slow rhythms intersected with human curiosity, revealing a world sealed away for generations. The sheer size and sudden motion of A84's detachment raised questions about how this ice mass had interacted with the underlying seafloor. Was the ecosystem down there dead, holding only remnants of past life? Or had some form of thriving life persisted in eternal darkness? These questions would soon be answered by the technology and expertise the scientists unleashed beneath the waves. The iceberg's break marked the beginning of an unprecedented journey into biological discovery, highlighting how dynamic and fragile Antarctic environments are undergoing rapid change. Scientists understood that what they might find had the power not just to reshape marine biology, but also to impact climate science and our broader understanding of Earth's ecosystems. As A84 drifted into open waters, it left behind a natural scientific laboratory waiting to be explored. The scene was set for the exploration vehicle, the remotely operated submarine known as ROV Sebastian, to descend into this hidden world and shed light on a mystery waiting beneath centuries of ice. First glimpses of an unexpected ecosystem. 12 days after the iceberg's calving, ROV Sebastian plunged nearly 2,300 meters below the surface, tethered to the research vessel and equipped with high-definition cameras and sampling tools designed for the crushing depths only machines can survive. As the cameras switched on, the scientists leaned in, prepared for a barren, lifeless landscape, in line with what textbooks had predicted. Instead, what appeared on their monitors stunned everyone into silence. Movement flickered in the darkness, multiple shapes drifting gently through the camera's frame, small creatures scurrying across rocky surfaces, and life thriving everywhere they looked. The pilot increased the ROV's lights, revealing a diverse and vibrant ecosystem that had long been hidden beneath ice nearly 500 feet thick. The scene contradicted everything marine biology had predicted about habitats isolated from sunlight and surface nutrients for centuries on end. Massive sponges, some nearly a meter in height, clustered densely over the rocks, their slow growth suggesting they might have been developing for decades or even centuries under the ice shelf. These sponges, growing less than 2 centimeters per year typically, hinted at a stable and enduring community. Around them, anemones clung to surfaces, brittle stars crawled slowly across the sponges, and solitary hydroids floated with delicate tentacles extended. Deep-sea coral stalks rose from the sediment like underwater trees. Even more remarkable were the larger, more mobile creatures. Octopuses rested quietly on the seafloor. Ice fish swam through the cold water using antifreeze proteins in their blood to survive frigid temperatures. And giant sea spiders the size of dinner plates moved steadily across rocks. Swarms of krill and amphipods gathered around the ROV's beams, hinting at a complex food web invisible to the naked eye, sustained by energy sources not relying on sunlight. Then came a jaw-dropping sight. A giant phantom jellyfish with an umbrella bell over 1 meter wide and ribbon-like oral arms stretching over 10 meters long, 33 feet in total. It drifted gracefully through a realm utterly cut off from the surface world, an alien presence in waters shrouded by centuries of darkness. This creature, along with the other diverse species, defied existing assumptions about where and how life could persist. These discoveries instantly shifted the researchers' expectations about Antarctic seafloor ecosystems, proving that life could flourish without the traditional reliance on sunlight-driven food chains. The scientific team was witnessing an ecosystem locked away, evolving independently under extreme isolation. It was a first-ever glimpse into biodiversity surviving in what was thought to be an ecological desert. The team's initial reactions were a blend of awe and disbelief. Some gasped involuntarily at the richness of life they saw, realizing that centuries-old ice had masked a thriving community beneath. The images sent back were historic, reshaping scientific understanding overnight. What had started as a routine expedition to study biodiversity transformed into a journey revealing one of Earth's last great biological secrets. This abundance of life beneath the iceberg's former resting place raised profound questions about how such an ecosystem could survive and what secrets its existence held for biology and beyond. The richness of this unusual ecosystem led scientists to investigate the species themselves and how their presence challenged fundamental biological rules. Species defying biological rules. The species documented beneath the iceberg shattered conventional biological expectations by thriving in what textbooks labeled as nearly impossible conditions. Giant sponges, standing nearly a meter tall and clustered densely, belong to communities that, based on their size, must have been established long before the iceberg's detachment. Their slow growth rates underscore a remarkable persistence in an environment thought too harsh to support such complex life. Among the sponges, anemones, brittle stars, and deep-sea corals created underwater forests. But it was the mobile fauna that astonished scientists the most. Octopuses, adapted to the Antarctic's bitter cold, rested quietly on the seafloor. Ice fish with antifreeze proteins preventing their blood from freezing swam through frigid waters. Sea spiders, some approaching the size of dinner plates, lurked quietly over rocks, defying typical size limitations for invertebrates at such depths. The crown jewel of this discovery was the giant phantom jellyfish, a species with a bell spanning more than 1 meter and oral arms stretching over 10 meters. This ethereal creature drifted silently in eternal darkness, surviving without any connection to sunlight. Its presence forced scientists to rethink the very parameters of life's resilience and adaptation in extreme environments. Normally, deep-sea ecosystems rely on the gradual fall of dead plankton and organic matter from sunlit waters above. Without sunlight penetrating the ice, such energy influxes cease. Yet these organisms not only survive, they appear to flourish. The methods by which these species have adapted to capture and process energy in total darkness shakes the foundation of marine ecology. The diversity noted during the expedition included 23 distinct megabenthic species visible to cameras, alongside vast microbial communities dwelling in sediments and on coral and sponge surfaces. Some of these species are likely new to science, evolving in complete isolation beneath Antarctic ice shelves for hundreds, possibly thousands of years. Specimens like a newly sampled isopod may represent entirely unique evolutionary paths. Antarctica itself has been isolated for millions of years by the Antarctic circumpolar current, a vast oceanic barrier. This isolation means species evolving beneath ice shelves have been cut off not only from sunlight-fed ecosystems, but from broader ocean biodiversity. This seclusion likely drove extraordinary biological adaptations, creating ecosystems unlike any studied before. The existence of such complex life in sealed, sunless environments suggests that energy sources beyond photosynthesis, the biological rules governing life's limits, need revision, embracing scenarios where darkness and isolation are not barriers, but unique ecological niches. These extraordinary species and their survival strategies lead directly into how life endures without sunlight in such forbidding settings, revealing resilience that has stunned scientists worldwide. How life survives without a sunlight. One of the most startling revelations from the expedition was how this ecosystem manages to thrive without any sunlight. Traditionally, marine ecosystems rely on photosynthesis as the foundation for sustaining life, with surface waters providing nutrients to the depths through falling organic matter. But beneath about 150 meters of solid ice, where sunlight can't penetrate, this usual food chain is completely cut off. So how do these creatures survive? Scientists suspect that ocean currents and submarine rivers play a vital role in delivering nutrients horizontally beneath the Antarctic ice shelf. Meltwater from the George VI ice shelf itself may carry suspended organic particles, dissolved nutrients, and chemical compounds processed by bacteria. This lateral transport of essential materials sustains the diverse and long-living species found on the seafloor below. Expedition scientist Laura Cimoli from the University of Cambridge explained that this glacial meltwater acts as a conveyor belt, supplying food and energy to organisms living far from direct photosynthetic input. Instead of nutrients drifting vertically from sunlit waters above, these creatures rely on horizontally transported nutrients flowing through the darkness. This means entire biological communities here have adapted to feed, grow, and reproduce in eternal night. This may include symbiotic relationships with bacteria, the ability to process chemical compounds, or extremely slow growth rates that suit the scarce nutrient supply. The discovery forces biologists to reconsider the limits of life and biodiversity in extreme and seemingly inhospitable habitats. Furthermore, the researchers documented at least 23 distinct megabenthic species visible during their short exploration in such a dark and cut-off environment. The possibility that many species found here are entirely new to science. The realization that life can sustain itself through such alternative nutrient pathways leads naturally to a cosmic perspective, one that stretches our understanding of where life might exist beyond our planet. Broader implications for astrobiology. The discovery of this vibrant ecosystem beneath centuries-old ice carries weighty implications far beyond Earth, especially in the growing field of astrobiology. For decades, scientists have speculated about the possibility of life existing beneath the thick ice layers of moons like Europa, one of Jupiter's largest satellites. Europa's subsurface ocean, sealed beneath up to 100 kilometers of ice and kept liquid by tidal heating from Jupiter's gravitational forces, represents one of the most promising places to find extraterrestrial life in our solar system. This shifts the perspective on icy worlds from theoretical habitability to genuine plausibility. It suggests that environments once dismissed as inhospitable might, in fact, harbor ecosystems sustained by chemical energy, bacterial partnerships, or geologically driven nutrient flows. The idea that photosynthesis is mandatory for life to flourish is no longer absolute. It's now possible that energy sources from below the ocean floor or through hydrothermal vents could sustain alien biospheres. But the Antarctic example also deepens the challenges of detection and study. Life in these dark, sealed environments might be slow-growing, sparse, and unlike anything we recognize from surface ecosystems. Remote sensing and sampling missions will need innovative tools and new ways of interpreting signs of biological activity. The lessons from Earth's hidden ecosystems provide a roadmap for understanding those distant worlds. This cosmic perspective offers both hope and urgency to ongoing planetary exploration efforts, as well as a reminder of the fragile, irreplaceable ecosystems on our own planet. The consequences of this discovery are not only about distant worlds, but return us to Earth's own rapidly changing polar environments and the challenges they now face. Threats to the fragile ecosystem. So now that the icy roof over Antarctica's seafloor is basically gone, the whole hidden ecosystem underneath is kinda staring at an uncertain future. And well, nobody knows for sure what happens next. For centuries, or maybe even millennia, these creatures have made it through in near total darkness, around near freezing temperatures, and with nutrient supplies that stayed steady under the ice. Then Iceberg, A84 drifted off, and sunlight started hitting the seafloor for the first time in who knows how many years, which is a big deal because it begins changing water temperatures, ocean movement, and those delicate conditions that kept this isolated community going. Researchers on the RV Falker 2 are basically running against the clock, collecting sediment cores, taking water samples, and gathering biological specimens before these shifts wipe out the good evidence. Every single sample gives clues about how those communities formed and moved under the ice, and also how they react when the environment starts changing. In the end, their results should sharpen climate models and help scientists forecast what happens next for Antarctica's ice shelves, plus what that could mean for global sea levels. This remarkable discovery beneath Antarctica's iceberg reveals life thriving where none was expected, challenging our understanding of biology and expanding the search for life beyond Earth. But it also highlights how fragile these hidden ecosystems are in the face of rapid environmental change. If you found this journey into the unknown fascinating, please like and subscribe for more stories that uncover the remarkable and often surprising truths about our world. Your support helps us bring science into clearer view.